Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and this is Nick, founder of Postgres AI. Hey Nick, how's it going?
Good. How are you?
Yeah, keeping well, thank you.
Yeah, so a long time no see. We skipped last week because of me doing some stuff at work and with family, so couldn't make it. Thank you for understanding, and I'm glad we are back.
Yeah, and no complaints from listeners, so thank you everybody for your patience.
Nobody noticed. They are still mostly catching up, we know.
Yeah.
Yeah, somebody shared on LinkedIn that I discovered Postgres FM, and while I was walking the dog, listened to all the episodes. It took me almost 2 weeks. 164 episodes during 10 days. It's challenging, right? It's like 16 episodes per day.
Yeah, that's binge watching.
Yeah, it's you need maybe 2x or 3x speed, and yeah, it's insane. So this topic we have today, it's not mine originally. It's from Maxim Boguk. I probably mentioned him a couple of times. He always has very interesting ideas and approaches to solving hard problems. And I remember he told me, it was maybe half a year ago, maybe more. He said, I squeezed more than 10 terabytes per hour when copying data directly from one machine to another. And for me, the standard was 5 years ago, it was 1 terabyte per hour. And I think I mentioned it a few times.
Yeah.
Yeah. We had an episode about how to copy Postgres from one machine to another. And 1 terabyte per hour, it's modern hardware, we know, there's a throughput for disks, throughput for network, throughput disks on the source and on the destination, both matter here. Parallelization, and SSD is good with parallelization. So basically, golden standard for me was 1 terabyte per hour. And if you need to create WolG or PG request backup, it was 1 terabyte per hour at least, right? And then we saw 2-3 terabytes if you raise parallelization with modern hardware. But it was still about not local NVMe, but about EBS volumes or PD SSD disks on Google Cloud, persistent disks on Google Cloud. And so traditional disks. By the way, those are also improved. ABS volumes are pretty fast these days, and the Google Cloud also has hyperdisks, which are impressive, but not as impressive as local NVMe disks, right? And Maxim told me that, of course, he was using local NVMEs. It was some self-managed Postgres setup with special machines, so local disks, and no snapshots like in cloud and so on, and PG request. And backups to where? To different machine or to S3? It doesn't matter here. The idea was how fast we can provision a replica, because sometimes we need it. For example, one replica is down or we reconfigure something, we need to build a replica. And normally if we have cloud disk snapshots, these days we use cloud disk snapshots. By the way, there is great news. Andrei Borodin implemented in WolG. Andrei is a maintainer of WolG. Implemented native support for cloud disk snapshots in WolG as an alternative to backup push, backup fetch. So instead of full backup or delta backups, you can rely on snapshots AWS, GCP, or others provide.
Yeah, I saw this. Is it a draft PR at the moment, or what's the status of this?
It just created a few days ago.
Nice.
Early. It was vibe coded mostly. Andrei is a great hacker, but I think our hacking Postgres sessions contributed to this idea. Let's do more code writing with LLMs. But of course, review will be thorough. I think it's already happening. I saw many comments. And the result will be improved and so on. So no hallucinations will be allowed, right? So all covered with tests and so on. Anyway, there is this idea that instead of full backups we can have snapshots, but at the same, I see two big trends. One trend is, okay, if we have snapshots for disks, let's use them more and more and more, and rely on cloud capabilities depending on cloud. Of course, such backups need testing and so on. In parallel, there is old idea, we should not be afraid of using local NVMEs. We know they lose data if machine is restarted. Ephemeral disks, right? But it's okay. These days, if machine is having issues, we usually just reprovision it anyway. And switchover or failover, it doesn't require restart, so it's very seamless. It means that we can live with local NVMEs, right? And additional momentum to this idea recently was created by PlanetScale, which came to Postgres ecosystem and started showing very good looking pictures in terms of benchmarks and real latencies from production systems. Of course, you cannot beat local NVMe disks with their 1 million to 3 million IOPS and amazing throughput, more than 10 gigabytes per second writes and reads. It's insane. Because for regular disks, we have 1, 2, 3 gigabytes per second only, and that's it. And IOPS, 100 to 100,000 IOPS maximum.
And I think for me, the critical part is if we have an HA setup with failover in place, then we don't need the durability of those disks. That we don't need there to be 6 cloud backups. So because we're going to fail over anyway. So it's that insight, and I think they did a good job of making that very clear. If you've got an HA setup, we can make use of the NVMe drives.
Yeah, by the way, I recognize I'm mixing throughput and latency. Anyway, local NVMEs are good in both aspects of performance and almost or sometimes full order of magnitude better than network-attached disks and so on. But you don't have snapshots. So two big downsides, you don't have snapshots, and there is hard stop in terms of disk size. If you plan to grow in 200 terabytes, you definitely need something like sharding or anyway, some way to split. Only if you have it, if you mastered it, then in this case, local disks are great for long-term planning. But for long-term planning, everyone should remember also that EBS volumes and PD, SSD or something, hyperdisks, they are limited to 64 terabytes. And both Cloud SQL and RDS this is hard limit for them as well. 64 terabytes. This is cliff or wall, very hard one. And Aurora has 128 terabytes, double of capacity. But anyway, if you self-manage, you can use LVM, of course, to combine multiple disks, and I think some companies already do it. But in case of local disks, it's really hard stopping. Nothing to combine, unfortunately. You usually combine multiple disks when you have terabytes of data. In my benchmarks, in our benchmarks, we combine multiple disks on I4I instances. So there is hard stop in terms of capacity. I think on I4I it's 40 terabytes or something like this. It's impressive, right? So if you think you won't grow to that size very soon, it's very great alternative to consider if you go self-managed or some self-Kubernetes managed setup compared to RDS. Because it gives you order of magnitude better performance, right?
Yeah. By the way, when you say our benchmarks, do you mean in the blog post you did with Maxim?
Yeah. So the original idea was by Maxim. He did the majority of initial work, created the recipe. I will tell the recipe and why it existed. But the idea was we need to copy from one machine to another as fast as possible. We don't have snapshots because it's local disks. Either fully maybe your own data center, or it's these instances with local disks like I4I, I7I. I remember I explored this idea very long ago, 10 years or so maybe, 10 years maybe ago with I3 instances at that time. I really like the cost of the final solution because the disks are included, instance costs are slightly higher, and performance is great. So we did a lot of benchmarks using i3 instances, even Spot instances. I remember it was great. So you get very cheap, very powerful machine and do with Postgres many things. So anyway, the goal was how to clone, to provision replica, for example, or to provision a clone for experiments.
Yeah, I wanted to ask about this because in the benchmark, for example, you turned off checksums. And it was interesting to me, like, about, because if you're provisioning a replica, presumably you wouldn't do that. But if you were doing it for some other reason, maybe you... yeah, so what are the use cases here where this would make sense?
Well, if it's a clone for experiments, we don't need to be super strict. And this option, I think, exists mostly for backups to make them super reliable and so on. Of course, and also, you know what, like, this is the extra feature RPG Backrest has, which, like, it's actually luxury to have it, right? You know, like, so yeah, of course, it would be good to see experiment with checksums enabled. Of course, results should go down, but for some cases, it's appropriate to disable that check.
That's a good point, actually. So if we don't have it, it's not... Is there a risk of introducing corruption, or is it more that we persist like if our primary is corrupted?
Well,
is it both?
Let me ask you this: if you copy data using PG base backup, who will check? Who will check this? Who will do that?
Yeah, good point.
Or you use rsync. Traditional ways are rsync and PG base backup. This is the most traditional way. Both are single-threaded. That's the point. Like, they are single-threaded. So, and there's no checksum. Like, this is extra feature. It's great that PG Backrest maintainers implemented it, and it would be good to compare how it affects this amazing performance we showed in this post. But anyway, the original goal was to be able to copy data with traditional way, not involving backups this time, because usually we normally. If not snapshots, we just fetch from backups using WolG or PG Backrest. And this is also very fast way, and there you can control also parallelization. You can provision quite fast. And S3 and GCS on Google Cloud, they are good with parallelization, like 16 threads, 32 threads. You can speed up significantly. You can increase throughput of backing up or restoring from backup. But in this case, okay, we don't have those backups. We just want to clone from one machine to another. That's it. And the problem is PG base backup is still single-threaded. There are discussions and even patch proposed to make it multi-threaded, but apparently it's not trivial. And I don't see current work in progress, so I think it will stay single-threaded. So Maxim came up with the idea that we could use PG Backrest not to create backups in S3 and then restore, because it's basically copying twice. Right? If you have them already, good, just restore. But if you need, if you don't have them somehow or cannot involve them somehow, you just have two machines and need to clone. In this case, he just came up with the idea, let's use PG Backrest to copy from one machine to another, that's it. It's not its primary job, right? But why not? And he told me, like I said, months ago, that he achieved more than 10 terabytes per hour. Yeah. Which is great, which is like absolutely great and impressive.
And multiple times what you thought was, considered good.
Yeah, so I already, from this fact and others, I already recognize that like 1 terabyte per hour is not a golden standard anymore. It's outdated. Yeah. We need to raise the bar, definitely. So maybe 2, at least. I don't know, maybe more. 3, 4, how much should be okay for modern hardware for large databases these days? Maybe 5 terabytes per hour should be considered as good, because you build some infrastructure and you see some numbers, and we have clients, not one client, many clients who come to us and complain. Okay, all backups take this amount of time, 10 hours. What's your size of database? 200 gigabytes. 10 hours, 200 gigabytes. Something is absolutely wrong, Maybe let's see where saturation is, where is the bottleneck. And it can be disks in many cases, but maybe network, maybe something else, mostly disks. But anyway, this is not normal. Sometimes it's software. and lack of parallelization and so on. But it's not okay to live with these bad numbers these days, right? It's already, we have very powerful hardware usually.
Just to ask the stupid question, what's the negative impact of it taking 10 hours?
Well, it affects many things. For example, RPO, RTO, right? You create backups, you recover a long time, it affects RTO. How much time, recovery target objective, how much time do you spend to recover from disaster? You lost all the nodes, how much time to get at least something working, at least one node working? If it's 10 hours for 200 gigabytes, it's a very bad number. You need to change things to have better infrastructure and software and so on. And this is one thing. Another thing is when you upgrade, for example, sometimes you need to clone. Our recipe involves cloning, a recipe for zero downtime upgrades. And if it takes so many hours, it's hard to think what will happen when you will have 10 terabytes. How many days will you need, right? So it's not okay. This requires optimization earlier.
And also for provisioning replicas, a certain amount of time taken is always going to be acceptable, I guess, because it's not the primary, right?
It depends.
Maybe we've lost.
If it's only primary, you are out of replicas. It's dangerous. Even with two nodes, running with two nodes, I would spend as less time as possible.
So when you say two nodes, do you mean with two replicas? Oh no, okay, so one
primary and one standby. It's already degraded state. We need a third node, right? To be in with three nodes, you have how many nines? 12 nines or so. Like if you check the availability of EC2 instances and just think about three nodes and what's the chance to be out of anything, this will be, I think, 12 nines or something, as I remember.
That is a lot of nines.
Yeah, and that's great. So it means almost zero chances that you will be down unless some stupid bug which propagates to all the nodes and puts Postgres on knees on all nodes simultaneously. Anyway, if we integrate it, and especially if it's just one primary, it's a very dangerous state. We have cases and some clients who run only one node, and we discuss it with them. It's not okay, but somehow these days they just survive because cloud became better. It doesn't die so often. Nodes don't die so often as before.
I also think there's this phenomenon where if you're in US East 1 and you go down, there's so many other services that are down at the same time that you kind of get not a free pass, but they get away with it a little bit more.
You're in the club, right?
No.
You are down, others are down. We are in the same. In the same club.
Yeah, I'm not in that club, but yes, I think a little bit.
No, I think we have also customers who got in that trouble as well, and they seriously think it's not okay, and they need multi-region setup. And I think this drives right now improvements in many companies and infrastructure and so on.
I'm glad to hear that.
Yeah, anyway, and with our one node is dangerous, I would provision more nodes sooner. And in some cases, you cannot live with one node. If you already relied on distributing read-only traffic among multiple nodes, one node won't be capable of serving this traffic.
Yeah, so we've established speed matters,
of course.
Time matters, therefore speed matters.
Yeah.
How do we go faster?
Yeah, so PG-based backup, I expected it's single-threaded, so I expect something 200, 300, 400 megabytes per second maximum. And this is what also, my expectations fully matched with what I saw Maxim shared with me. But when I started testing, I took two nodes, i4i, it's not the latest, it's third generation Intel scalable Xeon, which is quite outdated. They have already fifth generation i7i. So two nodes, 32 cores, it's 128 vCPUs, more than terabyte of memory, I think both, and 75 gigabit per second network. And the disks are I think it's 3 million IOPS, I remember. I don't remember how many megs per second, gigabytes per second. It's definitely somewhere 10 or more gigabytes per second. disk throughput maximum. I think 8 disks already in RAID. I took Ubuntu. I installed Postgres 18, and this was my mistake, because this gave me very good speed for PG-based backup. Unexpectedly, I saw gigabyte per second, and I was like, "Oh, what am I doing wrong here? Because it's too fast." And then I realized it's Postgres 18 improvements, right? IO Uring, and yeah.
Well, I saw you said that in the blog post, but did you run it deliberately with IO Uring on?
It's by default
No, it's not IO Uring by default. But it is using something similar. It's using something similar. It's like
then it's some prefetching or something, but it's definitely something.
Yeah, well, it does have 2 or 3 worker processes by default, and it is an asynchronous IO thing.
No, I didn't change that setting. So this is probably inaccuracy in my blog post.
But maybe not bad, because it might still be AIO, might still be asynchronous IO, just not IO Uring.
So, there is a setting IO method, right? And default is worker, right?
Yeah.
And it's asynchronous IO using worker process. Yeah, it's not IO Uring. I need to make correction.
But this is actually interesting, because I think the default is only 2 or 3 workers, which means if you increase that number, you might. So you triple, like
3 workers.
Probably got triple. Yeah. Wow. So you got roughly triple the.
Exactly. My expectations were 300. Yeah. But
if you increase that number, if you increase the number of workers, you might be able to get even more.
Does it mean I need to spend a few $100 again for these machines? Okay, I guess so.
Or an exercise to the reader.
How it worked? Like I started them like at 6 p.m. or something. I worked with them like something. Cursor did a lot of work. Like I just explained, control that I connected Tmax, IO start, IO top, everything. I see how many threads, everything, like htop, many things. So I see that it's doing work as I do. Many iterations to Polish approach. And then I realize, okay, it's already 9 p.m., 10 p.m., but I cannot drop it because it's already provisioned, and it took time to create 1 terabyte database. I had comments from Maxim as well that 1 terabyte is not enough. Like, okay, I agree. I should do 10 terabytes. So I guess I need to redo this. I have homework to do.
You don't need to redo it. It's just interesting...
it's interesting to me as well. Because I also want to see Postgres 17,
Yes.
and different settings here. I think it's interesting how PG-based backup can behave with various settings. More workers, IO Uring as well, sync as well, right? Synchronously. So not asynchronously like here, but synchronously. It should go down. The throughput should
go back down.
Yeah. So now I like, obviously you just make me do another round of this experiment, right?
Well, sorry, but I also think like this. Someone else could do this, right? Someone else could do this.
Yeah, I will have it in my to-do list. But if someone who is listening to us is ready to repeat, maybe they have already some good machines. Unfortunately, I don't have credits anymore, like I did in my company had a lot of credits, but not now. Maybe someone has credits and can provision big machines, and just to avoid extra spending. Because I think a few more times it will be already $1,000 just to check this setting. And I'm not interested in checking on smaller machines and then like extrapolating. No. It's boring and not serious. So it should be big machines. I would also check i7i. Because they have 100 megabit per second, it's versus 75, so also extra. And I think we can exceed 10 gigabytes per second. And so what I've got with PG-based backrest, with PG-based backup 1 gigabyte, I think you are right in terms of 3 workers. This is why, right? Interesting to check more workers. With PG backrest, I increased parallelization, and my blog post has this, like the graph showing how throughput was growing with more and more workers, and then saturation happened on network. So I achieved 36 terabytes per hour. And it was also exceeding my expectations. I was hoping like be close to 20 maybe, right? But
it
Yeah.
It sounds fake to me. It just sounds like not believable. But it obviously is impressive.
Yeah, so i7i with 100 megabit per second should give maybe more than 40, right? Maybe approaching 50 terabytes per hour. This raises bars and expectations what we should have in our systems these days. Right? So it should be normal. 5 terabytes per hour should be normal now, I think. Answering my own question some minutes ago, right? 10 terabytes should be not surprising already if you have local disks. With ABS volumes, different.
Yeah, for me, I guess the surprising thing is that we can saturate the network. Like it then becomes about your network, right? I think, and the number of cores.
Yeah.
And your disks.
And if you saturate a network, the idea is, of course, let's try compression. So I did. And compression improves things, but so it shifts the saturation point, but it's like quickly saturated again, and it was not helping to achieve more. Maybe I saturated disks there actually. Let me check one second. So if you look at the picture,
I'll pull up your blog post as well.
yeah.
Because you hit a peak around 32 parallel processes.
Also SSH overhead. I've got good comments on Twitter that it would be good to check TLS. It would require effort to configure, but it should also reduce some overhead, and throughput should be improved.
Wow.
So I guess 36 terabytes per hour is not the current limit for modern hardware in AWS. We can squeeze more, right? So we can probably squeeze up to 50 terabytes per hour. There are several good ideas, and also squeeze from PG base backup, right? So this is a competition, right? So my intention was to show PG base backup is bad, single-threaded, forget about it. Here's the recipe. Now, with Postgres 18, it's not that bad. It can be tuned additionally, as you say, probably, right? And we can have very good speed with it as well. So it's interesting. And 1 gigabit per second is more than 3 terabytes per hour.
Yeah, wow.
Yeah, 3,600 gigabyte per hour, right? It's more than 3 terabytes. So it's already good enough. And these are default settings. So the answer, should you use PGBack REST recipe? Well, it depends. With Postgres 18, with older Postgres, I definitely think you will be limited by 300-400 megs per second. That's it, because of single-threaded nature of PG base backup.
Yeah.
And I like this a lot compared to the tricks we did in the past with rsync. Rsync is also single-threaded, and I really don't like that. Why is it so? It should be implemented people use GNU parallel and so on, but it's so feels cumbersome, right? So it's not lightweight approach to write some things and then control the threads and so on. With rsync, it's definitely single-threaded. PG base backup in Postgres 18 basically shines compared to rsync.
Yeah.
And also it orchestrates all the stuff additionally, like connecting to the primary, doing telling it I'm copying you, right? PG start backup, PG stop backup, basically, right? So you don't need to remember all those things, and it's also standard, official way.
It's core.
Yeah.
Although I would say I was looking, because of researching for this, I was looking at the PG backrest docs and GitHub repo just earlier today, and it's incredibly well maintained. I was surprised to see.
Yeah, we're moving to David Steele. Yeah, it's great.
Well, yeah, kudos to David, but also just in terms of viewing a project for the first time in a while, I hadn't looked into it in detail for a while, and I think I was just a bit surprised when I looked at an open issue. I was like, there's only 54 open issues, that's for for the size of the project, for the age of the project. That for me seems like And by the way, I'm not taking that number on its own. Looking at what they were, like some of them are like feature ideas from a few years ago that are just left open because they're still good ideas. Some of them are new things.
That's good because there's approach when people just close if it's like, okay, no comments for a month, let's close. And I absolutely hate it because
Same.
if you reported a bug which is not fixed, cloud native PG, hello. Like they just closed because, right? Because converted to discussion, but bug is still there and everyone around agrees it's still there. Why do you close my issue? It's a bug report. So next time I won't write anything, right? And I told it everywhere. And in Cloud Native PG, I'm not going to contribute anyhow else. So this is let's just keep issues set lean, right? It's not okay. If it's serious problem of idea, it should be there. So the fact that there are old issues there is great.
Yeah, yes. So all I meant is you kind of get these, sometimes you get red flags when you look at a new project, or like if you see a project and it's got 20,000 open issues, for me that is a red flag. Like not that that there's lots of issues, but that no one's closing the ones that are duplicates or things. So it was more just like I wasn't getting red flags, and then there were loads of green flags looking at how like recent PRs, and it seemed like so I know it's not in core, but it does still feel like a very tried and tested product that's really well maintained, and I know a lot of people are using it.
Yeah, that's
so good. It feels pretty much as close to core as like a.
What if you see hundreds or thousands of issues open, but many of them are recent and there is activity, not well maintained, or what? A mess?
Spam issue? Like, how can you create hundreds of thousands of issues? I just haven't seen a repo like that, so maybe I have to like reassess. But it's Okay. Have you seen a repo like that?
I have such projects.
Oh, okay.
So it's just there are some old issues that should be closed. Yeah.
Yes.
Well, if you check, so I agree. This is a great example of well-maintained open source project. Absolutely great. I agree. I think if you check some internal repositories in companies, sometimes it's a mess as well, right? So,
and sometimes it's beautiful. It depends. I think it depends a lot on the maintainer.
What can you tell about Postgres itself?
Yeah, well, we don't have an issue tracker. Right?
Yeah, no issues, no issues, right?
We should get that. Would be a good T-shirt. No issues, no issues. All right, should we get back to the topic?
Back to the topic. So David still reached out to me commenting, and it's great. So some inaccuracies in my blog post to fix. And also, obviously, it inspired him to... as I understand, this idea was already for quite some time to have the feature to basically issue renice, to reprioritize some processes, right? So now there is a pull request to be able to change priority of PGBackrest processes, which is great.
So this is super cool. So this is the idea that because you're running this on production, you might not want to, let's say you're quite high CPU on your primary.
Compression, yeah. You use compression, so you need CPU for PGBackrest, for example,
Yeah, but you don't want to affect your current traffic, right?
It reminds me of old days, like 2003 or 4, when we also, it's so strange, like we couldn't think about terabytes those days, 20 plus years ago. It was too much. Terabyte it's mind-blowing number. But we used, I remember, renice, renice, ionize something, I barely remember from those.
Just nice, yeah.
Yeah, nice and so on. It's strange that this word is used to change priority, right? I don't know details. Do you know details here? Yeah.
No, I don't know.
Yeah. So I remember from those days we used it, but also I remember I was struggling to see good effects. So now if this pops up again, I would test it properly again, how exactly it helps. But this is in to do.
And really cool that these benchmarks helped prioritize that work. So cool.
Inspires to do more benchmarks as well. Right?
Always. I get stuck in that loop sometimes, not just with benchmarks, but you think you implement a feature, then you think of a better way to implement it, then you think of a better way, and you think of a better way, and you get stuck in that loop of constant, or blog posts.
This post is definitely not the final. So somebody should achieve 50 terabytes per hour. This is a challenge.
Yeah, I like it.
Yeah, who can do it? Yeah, who will be the first in Postgres community reporting 50 terabytes per hour?
Yeah, let us know.
Yeah.
Although I did see there was an issue that David linked us to where somebody maxed out 100-core machine, and it convinced him to increase he had a process max at 99 before then. So I thought that was quite funny that, there was the limiting factor was this hard-coded limit.
Maximum number of vCPUs on AWS already, I think, has it exceeded already 1,000 or no? I remember 700 or 800 vCPUs with also 5th generation Intel Zero Scalable. So it's already we have a lot. Well, if you
bear in mind your test maxed out at 32 processes, right?
Right, but
this
was
one
bumped into network.
Yes. Okay.
And then when I increased compression, it's shifted, right? So it shifted to 64 cores. So,
but I'm wondering, what do you think the person in the open issue back in 2019 that maxed out their 100-core, what do you reckon their throughput was?
I don't know.
Lower.
It's interesting, but maybe we need compression not only to battle network throughput limit, but we also, if it's actual backup, we want sometimes we want it to take as less space as possible in S3, right?
Yeah.
Just to pay less, maybe,
sure.
Right? In this case, we can have aggressive compression and CPU consumption high. Right, in this case, it can be 128 cores, for example. 3rd generation of Intel Scalable Xeon has 128 cores maximum, I think, at least in clouds. It's N2 on GCP and i4i as I used on AWS. So, but I wonder a lot, how come AWS created 700 or 800 vCPUs machines? It's like, wow. So 10 plus terabytes of memory. Wow. Yeah.
By the way, when you keep saying there was the Google disks earlier, I think you were saying that every time you said them, all I could hear was PTSD. And
PTSD, PD, SSD, persistent disk, SSD. Yeah.
I heard PTSD, and then when you're saying eye for eye, all I can think of is the saying an eye for an eye and the world is blind. So now, yeah.
Oh, by the way, one interesting thing, ABS volumes these days also are built on top of NVMe's. I don't know how is it called, Nitro architecture, or it's already the new name. I don't follow all the terms, but I remember 2 gigabytes per second and even more. Right, so I think we can squeeze 5 to 6, 7 terabytes per hour on modern EBS volumes as well.
Even on EBS, wow.
Yes. So forget about 1 terabyte per hour. It's old.
You can do better.
Yeah, definitely better. If you have large database, do better.
Nice. Yeah. All right.
Good.
Thanks so much, Nikolai. Enjoyed that. Take care.
Bye-bye.